Let's start this lesson by talking about identity and access management, often called IAM, which is one of the most important security foundations in AWS. At its core, AWS Identity and Access Management answers three critical questions. Who can access AWS? What they can access? And under what conditions that access is allowed? IAM is the service that lets you control access to your AWS resources in a secure, scalable, and auditable way. Every AWS account includes IAM by default, at no extra cost, and it's available globally. So the moment you create an AWS account, IAM is already there protecting it. Why IAM is so important? In the cloud, there is no traditional network perimeter like in on-premises environments. Identity becomes the new security boundary. That means IAM is not optional, it's fundamental. Using IAM correctly allows organizations to secure their AWS environments, scale teams and applications safely, enable innovation without sacrificing control. One of the biggest strengths of IAM is fine-grained permission control. Instead of giving users or systems broad access, you can define very specific permissions, such as allowing a developer to read objects from one S3 bucket, but not delete them. Allowing an application to write logs to CloudWatch, but nothing else. Allowing an admin to manage EC2 instances only in a specific region. This supports the principle of least privilege, which means give only the permissions that are absolutely necessary, nothing more. This reduces the blast radius if credentials are compromised or misused. Unified identity management. IAM also helps organizations manage identities at scale. You can manage users and roles inside a single AWS account, or centrally manage access across multiple AWS accounts using IAM Identity Center. With IAM Identity Center, companies can use a central place to manage workforce access, integrate with corporate identity providers, assign permission sets instead of managing individual IAM policies everywhere. This makes access management cleaner, more secure, and much easier to audit. Temporary security credentials. Another key concept in IAM is temporary credentials. Instead of long-lived usernames and passwords, AWS encourages short-lived credentials, automatically rotated access keys, role-based access for applications and services. For example, an EC2 instance assumes an IAM role to access S3. A Lambda function uses a role to write to DynamoDB. A developer signs in via IAM Identity Center and receives temporary permissions. This approach significantly reduces the risk of credential leakage and improves overall security posture. Access analysis and policy validation. IAM doesn't just control access, it also helps you analyze and improve it. AWS provides tools that identify unused permissions, detect overly broad access, help generate least privilege policies based on actual usage. This is especially important over time, as environments grow and permissions tend to accumulate. Regularly analyzing IAM permissions helps organizations reduce security risk, stay compliant, keep access aligned with real business needs. To summarize, IAM is the foundation of AWS security. It controls access for both people and workloads. It enables least privilege, scalability, and secure automation. And it plays a critical role in every AWS environment, small or large.
All right, so at this point, go ahead and pause the video. Take a moment to read the question carefully and try to answer it on your own. Once you've made your choice, resume the video. Next, I'll walk you through a few clues to help you identify the correct answer.
This question is asking which AWS service is responsible for controlling access, specifically, who can access AWS resources and under what conditions. That wording is very important. Here are a few clues to help you narrow it down. Focus on services that define permissions, not ones that only monitor or record activity. Think about fine-grained access control, where you can allow or deny very specific actions on very specific resources. Ask yourself, which service is used every day to manage users, roles, policies, and permissions in AWS? Be careful with services that are related to auditing, logging, or security scanning. Those are important, but they don't control access directly. Keep those clues in mind, review the options carefully, and try to identify the service whose primary purpose is access management. In the next slide, we'll reveal the correct answer and explain exactly why it's the right choice. The correct answer is AWS Identity and Access Management, IAM. IAM is the service that allows administrators to define who can access AWS resources and under what conditions by using users, roles, and policies. It provides fine-grained permission control, which is exactly what the question is asking for. Let's take a moment to talk about why protecting the AWS root user account is so critical. When you create an AWS account, AWS automatically creates a root user. This identity is different from all other users because it has unrestricted, full control over the entire account. The root user can access every service, every resource, all security settings, and all billing features without any limitations. Because of that, the root user can perform actions that no other identity can. For example, only the root user can close the AWS account, change the account's primary email address, modify certain billing and tax settings, or recover access if permissions are accidentally locked down. These are powerful, irreversible actions. Now, think about the security impact. If someone gains access to the root user credentials, they don't just get access to one service, they gain complete ownership of the entire AWS account. They could delete resources, steal data, run expensive workloads, or lock the real owner out entirely. That's why the root user is a high-value target for attackers. For this reason, AWS best practice is very clear. The root user should not be used for daily work. Instead, it should be reserved only for tasks that explicitly require root access. After the account is set up, all regular administration and operation should be done using IAM users or roles with carefully scoped permissions. In short, protecting the root user is about protecting the entire AWS account. Treat it like the master key to a vault, used rarely, stored securely, and guarded with the strongest security controls available.
All right, so at this point, go ahead and pause the video. Take a moment to read the question carefully and try to answer it on your own. Once you've made your choice, resume the video. Next, I'll walk you through a few clues to help you identify the correct answer.
Let's look at this question together and reason it out step by step. Key clues to guide you. The root user has full, unrestricted access to the AWS account. AWS best practices strongly emphasize minimizing root user usage. Any action that increases exposure of root credentials, sharing passwords, embedding keys in code, daily use, is a major security risk. AWS consistently recommends adding extra layers of protection to the root user rather than using it more often. Ask yourself, which option reduces risk, limits exposure, and follows AWS security guidance? The correct answer is, enable multi-factor authentication, MFA, on the root user and avoid using it for daily tasks. Why this is correct? MFA adds a critical second layer of protection, making it much harder for attackers to compromise the account, even if the password is exposed. Avoiding daily use reduces the chance of accidental exposure, misuse, or credential leakage. This aligns directly with AWS best practices. Lock down the root user and use IAM users and roles for everyday operations. Let's talk about one of the most important security principles in AWS, and really, in all of cloud security, the principle of least privilege. At its core, least privilege means this: every user, application, or system should have only the permissions it needs to do its job, and nothing more. No extra access, just in case, no broad permissions for convenience. This simple idea dramatically reduces security risk. Why is this so important? Because most security incidents don't start with a total system breach. They start with over-permission access. If a compromised user or application has limited permissions, the damage is limited. If it has broad permissions, the impact can be massive. In AWS, least privilege is primarily implemented using IAM policies. These policies define who can act, users, roles, services, what actions they can perform, on which resources, under which conditions. The goal is to be as specific as possible. A good starting point is to begin with minimal permissions. Instead of granting full access and locking things down later, start with an empty or very small policy and add permissions only when they are actually required. This approach may feel slower at first, but it leads to much safer environments. AWS also helps you refine permissions over time. IAM last access data shows which services and actions are actually being used. If a permission hasn't been used in months, that's a strong signal it can probably be removed. Another powerful tool is IAM Access Analyzer. It helps identify overly permissive policies, unintended access, especially from outside your account, and unused access paths. This makes least privilege a continuous process, not a one-time setup. Least privilege isn't only for people. AWS services should also use service roles. For example, instead of giving a developer broad permissions to deploy infrastructure, you can allow CloudFormation or Lambda to act on your behalf using tightly scoped roles. This reduces human access and improves security and automation. Least privilege is not set it and forget it. Jobs change, applications evolve, and permissions must keep up. That's why regular permission reviews are essential. AWS services like CloudTrail and AWS Config help here. CloudTrail logs who did what and when. AWS Config tracks configuration changes and checks compliance against rules. Together, they give you visibility and accountability, adding extra layers of protection. Finally, AWS lets you reinforce least privilege with additional control layers, such as permission boundaries to limit how powerful a role can become, service control policies, SCPs, to enforce organization-wide guardrails, session policies for temporary access, VPC endpoint policies to restrict access at the network level. These layers ensure that even if one policy is misconfigured, broader safeguards remain in place. The principle of least privilege is about intentional access. Give only what's needed, review it often, and continuously refine. When done well, least privilege reduces risk, improves compliance, and makes your AWS environment far easier to manage and secure.
All right, so at this point, go ahead and pause the video. Take a moment to read the question carefully and try to answer it on your own. Once you've made your choice, resume the video. Next, I'll walk you through a few clues to help you identify the correct answer.
Let's look at the next question together. In this scenario, the company is reviewing IAM permissions and notices that some users have very broad access, like S3 and EC2. That's a classic sign of over-permissioning, and it directly conflicts with the principle of least privilege. Before jumping to the answer, here are a few clues to guide your thinking. Least privilege is about reducing access, not expanding it. AWS does not automatically decide permissions for you, you must define them. Broad, wildcard permissions are exactly what least privilege tries to eliminate. The goal is to give users only the actions and resources they actually need, no more. Take a moment and think. Which option tightens access in a controlled, intentional way? The correct answer is, replace broad permissions with custom policies granting only required actions and resources. Why this is correct? This option directly applies the principle of least privilege. Instead of allowing all actions on all resources, you create fine-grained IAM policies that specify exactly which actions are allowed, for example S3, get object instead of S3, exactly which resources can be accessed, specific buckets, instances, or ARNs. This minimizes risk while still allowing users to do their jobs effectively. Let's talk now about AWS IAM Identity Center, which used to be called AWS Single Sign-On. Think of IAM Identity Center as the central access hub for people, not applications. Its main goal is to simplify how workforce users, like employees, developers, and administrators, sign in and access AWS accounts and AWS managed applications securely. Instead of creating and managing IAM users separately in every AWS account, IAM Identity Center lets you manage access from one place. From there, you decide who can access which AWS accounts, what they can do, and under what role, all using centralized permission sets that map to IAM roles behind the scenes. One of the biggest strengths of IAM Identity Center is single sign-on. Users sign in once and can then access multiple AWS accounts, AWS managed services like Amazon Redshift, Amazon Q Developer, or the Amazon Quick Site Console. Supported third-party applications. This dramatically improves both security and user experience, because users don't need multiple credentials or long-term access keys. Another key capability is identity provider integration. IAM Identity Center can connect to existing corporate identity systems such as Active Directory, Azure AD, Okta. This means organizations can keep using their existing identity source, while AWS simply consumes those users and groups. If an external provider isn't available, IAM Identity Center can also manage users directly, making it flexible for startups and smaller teams. From a security perspective, IAM Identity Center encourages best practices. No long-lived credentials for humans. Centralized access reviews. Easy onboarding and offboarding of users. Clear separation between identity management and permissions. In short, AWS IAM Identity Center is the recommended way to manage workforce access at scale. It brings together single sign-on, centralized permissions, and identity integration to make AWS access simpler, safer, and easier to govern.
Alright, so at this point, go ahead and pause the video. Take a moment to read the question carefully, and try to answer it on your own. Once you've made your choice, resume the video. Next, I'll walk you through a few clues to help you identify the correct answer.
Before you look at the options, ask yourself, if a company has multiple AWS accounts, do they want to manage users separately in each one, or from a single place? Which AWS service is designed specifically for workforce access, not application end users? What service provides single sign-on, SSO, so employees log in once and access many AWS accounts and AWS services? Which option reduces password sprawl, manual user creation, and long-term access management overhead? Is this about human users accessing AWS or applications authenticating end customers? Now that you're thinking in terms of centralized workforce identity, single sign-on, and multi-account access, let's look at the question and the answer choices. The correct answer is, use IAM Identity Center to manage user identities and assign permissions across multiple accounts. IAM Identity Center, formerly AWS SSO, is built specifically for centralized workforce access. It lets organizations manage users in one place, provide single sign-on, and assign permissions across multiple AWS accounts and AWS applications using permission sets mapped to IAM roles. Why the others are wrong? Creating IAM users in every account leads to poor scalability and security risk. Amazon Cognito is for application end users, not workforce administrators. AWS Directory Service helps with directory integration but does not manage permissions across accounts by itself. This makes IAM Identity Center the clear best practice solution.
Thank you for watching. See you in the next class.